ये क्या हाल बना रखा है?
इंजीनियरिंग तो पढ़ ली लेकिन प्रैक्टिकल नहीं सीखे। करता कुछ हूँ, होता कुछ और है। भाई इस बार ना मेरा फेल होना पक्का है।
ऐसी पढ़ाई का क्या मतलब जिसमें हो नो प्रैक्टिकल्स? चुपचाप जाओ इंटर्नशाला ट्रेनिंग्स पे। यहाँ है 3D प्रिंटिंग, रियल एसआई, वेब एंड ऐप डेवलपमेंट, प्रैक्टिकल लर्निंग वाली ट्रेनिंग्स। ट्रेनिंग सेलेक्ट करो और थ्योरी के साथ प्रैक्टिकल भी सीखो। इंटर्नशाला ट्रेनिंग्स, शुरुआत यहीं से।
Hello and good evening, everyone. I'm your host, Manpreet. Welcome to the sixth season of IST Practicals by Internshala Trainings. IST Practicals is a series of free online masterclasses delivered by industry experts. These 45-minute sessions are all about teaching students important concepts, softwares, and tools. Every IST Practical is an opportunity to experience the power of practical learning. In today's session, we have Sana Khan. She is a specialist working in the field of instrumentation, ML, AI, and biomedical devices. She has worked as an embedded product designer in the past and is also the co-founder and instructor at Practical Ninjas. I hope you will enjoy this webinar with her. We have a very special gift for you at the end, so stay tuned for that. तो चलिए करते हैं PLC की शुरुआत यहीं से and let's welcome Sana.
Hi, thank you, Manpreet. Hi, everyone. I hope you're all doing well, and I'm really glad to be speaking to all of you on one of the most buzzing topics, and it's the next big thing. I know you all must have heard about automation, PLC, what it's all about. So, here I would be giving you a very short introductory webinar on the role of PLC in automation. So, I hope you guys are excited because I am. So, let's dig in. I just want to give you a small overview about what we will be talking in this session. I will be talking about the industrial automation in a simplified way. We will look into the controllers which are used. Here, our prime focus would be PLC. And in the end, we will wrap it up by taking an industrial case study and we will try to build it using a programming language. So let's begin. And before starting it all, I want you to be a bit more interactive and use the chat box that we have here. So there's a quick poll and I'll be showing you two images. And I want you to look at the two images and tell me which one is an automated process and which one is manual and which you would go for. So the problem statement is here. You can see the two images 1 and 2. Now, in the process, we have to fill the tank with water. And to fill the tank with water, there is a pump which will allow the water to go into the tank. And there is a valve, as you can see here, which will let the water in, or once you close the valve, it will stop. Now, in the image 1, there is a person who is controlling this valve, whereas in the image 2, you don't see this person, but you see some other components which are doing this work. So putting the question out again for you to answer, which of the two images, 1 and 2, is the automated process and which one you'll go for? All right, I think everyone is really very interactive. I'm really happy to see this kind of interaction. Wow, I guess everyone over here is an expert. All right, so as you all guessed it properly, yes, image number 2 is the automated one, and we would be going for this process. And why is it so? Let me just give you a small brief about it before we dig deep into it. So in the image 1, this person is standing over here on the tank and there is a viewing glass. Now this person has to continuously look at the viewing glass and see, okay, is the tank underfilled? Is it overfilled? I need to be continuously monitoring it, and I will be needing to, switch on and off the valve. And in the second case, there is a sensor which is placed inside the tank. which will tell you the level of water in the tank. And this will be given as an input to the controller. The controller does a sort of computation that we have decided to do it. Don't worry, we will talk more into it as we go, how it is done. And this computation will give a feedback to the control valve, and it will automatically decide, okay, the level is filled, I need to close the valve, no water needs to go, or the tank is underfilled, I need to keep letting the water in. So definitely image 2 is the automated one, as you all have guessed. And why we would be going for an automated process is because we are taking a very small example, of a person actually looking at the water level and is filling the tank. But in case of processes which are going day and night, which have multiple inputs, multiple outputs to be controlled, and there is a high level of precision which is required, you would be going for an automated process. So let's decide more on this. Let's discuss more on this and talk about what is really automation. So automation is the use of technology to perform tasks with very less or reduced human intervention. So for any process which is repetitive, we will be using automation over here. As you can see in the image, the automatic bottle filling machine, how easily this has been doing for filling the bottles and putting a lid and a stamp on it. And you may wonder, what are the benefits of automation? There are numerous ones. So, for example, the safety of the work people who are there on the production line. We hear so many instances of so many errors which are happening, which leads to health of a safety personnel being compromised. So when we use automation, we see to it that all the older equipments are being detected, we retrofit it with the new ones, and the personals who are working over here are safeguarded. It reduces time. By using automation, definitely the amount of product and processes that you are releasing into your production line, it takes very less amount of time to be done, and that helps in getting a lot of work done quickly. And one may ask, there is really no use if you are delivering product into the market, but they are of low quality. It gives so much errors. The bottles which are filled, if they are underfilled or there is spillage. So once you are programming your controller to be automated, it is very important that the logic that you are putting into it has no errors so that it can work efficiently. And that is the beauty of automation. You can detect these kind of errors very quickly, very easily, and they are very easy to be fixed. And everyone in the market needs product which is 100% assured. So you will have a very good customer satisfaction when they are very happy with your level of work which is being delivered. And definitely the staff which is over there, we are not replacing them. They would be promoted to a very higher level of work where they are simply supervising the task. They are promoted to a higher level of work where they are using a human machine interface to simply control and navigate through the process which are present here. And all this amount of benefits definitely increases the productivity, your profit level goes high. Thus, your efficiency goes high, which leads to more productivity. So, all encompassing, that is the beauty of automation that we have seen over here. So, we will be having in between quick quizzes just to see how much you're gauging it. So, I will take you to the LMS of Internshala. So, this is a multiple choice question over here, that what are the benefits of automation? And you need to select A, whether it saves time, B, it increases production rate, C, it reduces errors, or D, it's all of these. So kindly put in your message in the chat box so that I can send it. All right, D, that is correct. I guess everyone is very attentive. Thank you so much. So that's the correct answer. And let's get back to the presentation. Thank you, everyone. And then we will talk about what is the implementation of automation in industries. So there are plethora of industries which are using automation, or we are moving towards automating processes. We hear it time and again, that, we need to automate this, we need to make it fast, we need to get it delivered quickly. So in the industrial automation, like in the bottle filling or the tank filling, those are some of the examples. But there is an automatic temperature control that you need to do. In these cases, industrial automation is widely used. Then you have the IT automation. Here, what will we do is, when you have a repetitive set of tasks, we will be having a system of instructions which will be operating using the standard operating environments, and you will be able to automate your IT industry as well. It has been widely used in the IT industry as of today that I speak. And then in the business automation and in the business process automation, again, there is a use of small softwares and algorithms are being used, from small level of softwares to high level of softwares to completely automate it. And why do we do that? Is because we need to tap into continuously the change in markets which are happening. Our processes need to be agile, and it needs to improve our interactions and engagement with the customer. Again, a field that you've been hearing is the robotic process automation. We've been seeing robots everywhere. They are used in surgeries, they are used in manufacturing, they are used for lifting heavy instruments where people were employed to do so. And there were a lot of hazards to the personnel that we saw if in case there were some errors. So the whole process is not to replace humans. It's basically to reduce humans to act less like robots, and for the robots to learn more like humans, so that humans can take up more important or bigger tasks. And definitely these three fields which I have personally worked on is artificial intelligence, machine learning, and deep learning. So these are like really very important fields buzzing, where people are taking interest in. And just to give you a small information about what my contribution was that when I worked in the medical industry, there were these series of images where doctors were required to analyze the severity of the disease which is present. Of course, we have lived through the pandemic and a lot of diseases are happening, and we see that the people who are responsible to diagnose it and tell you, okay, you are suffering from this, what medication needs to be given, we were shortly understaffed and not prepared for that amount of work. So with respect to predictive algorithms which are present, you can easily diagnose what level of criticality is there, and you can let the patient know about it as quickly as possible. Now, this is just with respect to medical industry that I have spoken about. Again, this is used in Tesla, the automated cars that we are seeing, which are coming up right now. So these are some of the industries where we are seeing that automation is being used, and different other parallel technologies like artificial intelligence, and these things are really getting overlapped now. That's quite interesting. And let's move on to a short quiz again here. So you need to put in which of the following is a process that can be controlled automatically. A, filling up the tank with chemical to a certain height. B, running the conveyor belt at a constant speed. C, baking bread in an industrial oven. Or you think it's all of these? So put in the chat box the right answer for this. All right. Sagar, Ajay, everyone putting D. Thanks so much. Yes, as you can guess it, you name it and there is automation over there. All right. Thank you so much, everyone. Thank you for your responses. Lovely. All right. Thank you. So moving on. So we've been talking about automation. Let's open up this automation and see what it is composed of, and let's try to learn all of these components together. But put this in a very simplified way over here so that you don't get bogged. If I have to divide the components of automation, I will simply put it in the 4 components that you can see over here. There is a sensor, There is a controller, actuator, and you need to define the process that you are automating over here. So in the previous example also that we have, you need to have different types of sensors which are giving you information. So these sensors, as we know, they will take up data from the physical environment. And we have numerous sensors over here. And you have seen the LDR, which is a sensor which is used to measure or detect any changes in the light intensity. Thermocouple, as the name suggests, it tells you the temperature. Hygrometer, it tells you the changes in the humidity level in the environment. Accelerometer will detect any sorts of vibrations or accelerations that you have. Like, for example, in your car, you will have, in your phone, you will have. Level sensor, the sensor we just talked right now, will indicate what is the level of the particular fluid that you're trying to measure. PIR, any amount of infrared radiation that you're checking. Touch sensor, simply your phone, which you use to lock or unlock using the fingerprints. So we are just surrounded by so many sensors, really. The second block that you can see is the controller. Now, this data, which is sensed by the sensor, needs to be given to a controller. Now, the controller is the brain that will basically make use of the data which is coming from the sensor. It is in the controller that you will put the operation that you need to perform. Okay, I need to control the level of water in the tank. I need to set my room to a particular temperature. So these are the kind of control mechanisms that the controller would do. And what are the controllers that we are seeing in the industry? If you have worked in these fields, they would be Arduino, 8051, PLC, which is a programmable logic controller, which we'll see in the next slide, or it could be the simple mechanism through which we were both talking. It's the simple computer that we are seeing. So this controller will put in where we will put all the algorithms to control it. And the data from the controller need to be put to an actuator which will decide what is to be done. Okay, my process was to basically close the valve. So that is what is to be done. Or I need a motor to go on when my light goes off. Or I want an alarm system to go on. I want the heater to go on or the heater to go off. So these are basically the mechanical devices which are the actuators. So if you've understood the components which are put on the left-hand side, I have put the image of the previous example that we have considered of the level sensing mechanism over here. So let's try to correlate both of them. So here, my process is to control the valve to basically switch it off when the tank is filled to an optimum level. So here, what is the level sensor that we have the employed is the LT sensor that you can see over here. Now, this level sensor will continuously monitor the level of water in the tank. It will go to the controller. Now, the controller, inside the controller, I have programmed it using one of the programming languages. Depending upon the controller, I'm using the type of, programming platform that I am using. So I will put a set point in my controller that this is the level I want it to be filled. And the controller will continuously monitor whether it has come to that same level or not. If the controller detects that, yes, this is the level of water in the tank that I want, it will send a feedback to the actuator. And what is the actuator we have over here? It's a control valve. Now the valve will be just turned off when I have got the proper amount of set points. So using just the level sensor and controller, I have automated this small example which is present here. All right, I hope you guys are able to understand and we are not getting bogged down. So let me go back to the next question. Which of the following is a sensor? Is it A, LED, B, thermocouple, or C, motor? So here I have put some input devices and output devices. All right, Pratik, you have mentioned A, which is an LED. As we have seen before, LED is an actuator. It will give a response of my work that the controller has done. Yes, so it is B because uh, thermocouple will basically indicate the changes in temperature. It will be indicating that temperature is my measurement parameter over here, whereas motor is again an actuator, which is a mechanical device. All right, thank you. So going back to the presentation, to our main topic over here, which is the programmable logic controller, also abbreviated as PLC. So over here at the left hand side, I have shown diagrammatically how the PLC looks. There are different PLCs which are available in the market. So just to talk about what a PLC is, through the diagram that we can see, you can see that there are different input terminals over here. There are different output terminals. These terminals are basically the ones which talk to with your sensors and actuators. There is a power supply and there is a small UI for the programmer to go and program it. So PLC stands for Programmable Logic Controller. It works on logic, and it's basically an industrial computer. Why PLCs are used so prominently in automation industry is that where you deploy these PLCs, they are used in a very harsh environments. So for example, there will be an environment in which I need to measure the temperature, and the temperatures really go very high. Like for example, you're using in a boiler system or something like that, or you're using it in an environment where there is a lot of dampness, there is a lot of wind. All other controllers might probably just fail to be in that environment. So it's a very rugged controller which we can use, and there are countless applications. The ones that we have discussed so far, it can be used, and it can be used in other industries like the glass industries. If you have an assembly line system, we can use over there, and we can also use in an automated car washing system. These are just some of the ones that I have mentioned here, but you name it and you have got it. So this is just a small introduction. We'll move further into how the architecture looks like. So that's where I will go into the next slide. But before that, just to see that you are following up, quick question, very easy one. What is the full form of PLC? Is it a logical conditioner? Is it a programmable logic controller? Is it a container? Or is it a peripheral logic controller? All right, I think you are all correct. And we will see in the next session how to program this logic controller. Great. Thank you, Ravi. Thank you, everyone. Pavan. All right. So programmable logic controller, this is the architecture of my PLC. As you can see over here, we'll just take you step by step of what are these components inside. But before that, I just want to correlate it with the previous slides that we have been working. My PLC would need sensors, just to get me the parameters that I want to measure. So there'll be a sensor. Of course, this is the controller that we are looking at. And then there is an actuator, right? That the lamps, the relays that I want to control. So in between these dotted lines is something that I would talk to you about more, and what's basically happening over here. So I have my sensors and I have my actuators, and they would be connected using wires to my PLC, right? So there needs to be some mechanism which connects to them. So these are my input modules and the output modules. So I will have the wires which connect to the input modules and the output modules. Now these modules are variable again. In the industry, they will have 4, 8, 12, 16 input modules and output modules, so much. And inside it, we can see the processor, which has the data memory and which has the program memory. Now, whenever you as a person who has become an expert or who is beginning to start with it, goes about it, and you need to put in your logic into your controller, you will be putting the program in. So that program gets put into the program memory. The processor that you can see over here will basically perform the computation that you have made your PLC to work on. And how do you do that? So there is this, there can be a handheld programmer, or using a simple PLC, you can program your device to put in the computation that you needed to perform. And then it's an electrical device, so it would need a constant stabilized power supply to work. So it's really very easy. That is why it's one of the very popular controller which is used in automation. And I just wanted to talk about some of the industries or manufacturers of PLC that we can see in the industry. And they are very popular. So we have Siemens, Omron, Allen Bradley, Mitsubishi, Honeywell, Schneider Electric, Hitachi. I mean, these are some of the very common ones that we see in the industry, how these PLCs are. So, and these are like big devices when we have in our industry. So usually the functioning that goes behind the PLC remains same. It will just differ in simple functionality. And once you have a hands-on one PLC, it becomes very easy to work on any PLC really. Quick quiz again. So, where do you use PLC? As in which industry? A, textile industry. C, cement industry. B, cement industry. C, paint manufacturing industry. Or do you use in all of these? Great. Thanks, Manisha. Lovely. Yes, I think again that again calls for one of the beauties of PLCs. You can use it in almost all the industry that you are seeing. Thank you, Muzammil. Going back to our PPT again. All right, thank you. So let's try to connect all of these components that we have been talking together. Is how to program the PLC. And so I have my controller, I will have the input devices, I will have the output devices. Now let's talk about what this control logic is and which programming languages does the industry use to program my PLCs. So I am listing just some of them over here. So we have a functional block diagram, FBD. We have a ladder logic program, which you can see on the right hand side. And we will talk more on this. So FBD and ladder logic are some of the very popular programming languages of PLCs that we have seen. There will be sequential logic, and there is a structured text. Now again, this comes at the dispense of the programmer, which logic that they want to use, or the PLC that they are using, it's adaptable with, or sometimes it's a requirement of the customer. So it again depends upon what kind of functionality that you have or the requirements that you have. So let's talk about what this control logic is and what this PLC programming actually looks like. So when I talk about logic programming, that means you have the physical inputs of the sensor and you have the physical outputs of the actuator. But in the PLC programming, you need to put it in the logical inputs and outputs. So that is how these inputs and outputs are represented. But I need to guard them. So how are they guarded? Firstly, you can see these two long vertical lines. These are the power rails. I have spoken already. It's an electrical device, and the power flow is from the left to right. Okay, and then you can see these big horizontal lines which are connecting the two rails, right? So these every horizontal line that you can see is called a rung. And every rung will be a control logic that you want to implement. So in my controller, I have multiple controls that I need to do. For example, I need to measure the level of the water in the tank. Based on the level of water in the tank, I want to add another sort of fluid into the tank once it reaches. So there are different operations that go in, right? So based on that, there will be different rungs over here. Each of the rung will talk about a control logic that you have implemented. And then when you have these small rung inputs and rung outputs, What are these? These are again logical representations of my input and output. So now when you have the sensor, level sensor, I cannot represent it in my ladder programming just as it is. I need to have a logical representation of that, and that is represented through my rung input. Similarly, the actuators are denoted by these curved brackets that you can see towards the right side of the rung. All right, I hope everyone is clear till now. So these rung inputs, let's talk about a bit more about what these rung inputs are. So for example, in the figure that you can see over here, there is a push button, right? Everyone knows what is a push button. When like for example, your doorbell, right? In its normal state, it is not pressed. You will not hear anybody is on the door because they have not pressed it, right? And once you push it is when you can hear the bell ringing. So that's a normal example of a push button. And what happens in a push button is that in the normal state, when it is not compressed, the electricity is not flowing through the path that I have defined, right? We can say that it's in an off state, or it's in a logic zero state. It's a low state. These are some of the terms that you will be hearing more in this session. So I just want to talk about it. And once you have pressed the push button, the circuit is completed. It's in the on state. You can see the switch over here is closed, right? So these kind of logical switches, when you used in the PLC programming, these are called as normally open contacts. That is why they are represented by these small two lines that you can see. There are other types of contact also that are there, which is called as normally closed contact. So what it is that it is, we have used the same push button over here. That means that when it is not pressed, my contact is closed, right? Electricity is flowing, it's in the on state. And when you press this push button, your contact will be open. The state will be made off, or the connection will be disconnected. And why do people use these two type of contacts? We can use one. It again makes your programming easier. We want to use as many as less redundant processes. When I'm writing my control logic, I don't want to make a very long programming for a very short thing which can be done, because I need to execute it fast, right? These are very quick. It needs to save time. So that is the reason why we use these kind of controls, different types of inputs that are present. And similarly in the outputs, there are no changes, because it would simply go on and off as per the input and the control logic that you have put. All right. So these are the input that we have spoken about, and the output devices. And now let's talk about the control logic that we are using. So inside the PLC, when there are different operations that you can perform. So can you think of some of the operations? For example, when I had the level sensor, I was actually comparing it with a set point, right? So there was a comparator used. Similarly, there can be Boolean instructions. And if you have a little knowledge about how Boolean expressions are, you might have learned about AND gates, OR gates, exclusive OR gates, NOT gates. I mean, there are many more gates over here. So we can use these Boolean operations also in your PLC, just to give a bit more clarity on what these gates are. So these gates, as you can see, the AND gate, there are two inputs over here, these two lines, and there is one output which is coming out. And in the AND gate, there is some algorithm which goes in, is that when both the inputs are high, your output goes high. Otherwise, it doesn't. In the OR gate, again, if one of the inputs is high, when I say high in the sense like it is connected, or it's in the on state, or it's in the logic 1 state, then also your output will be on. So if you see the symbolic representation of the AND gates here, it will basically take the location, of that A and B. A and B are the two inputs, and this N7 is to 0. These are the memory locations inside the PLC where the data will be put in. And again, it will be like a numeric value, floating value. Those are the different indications that you use. And in the destination, what value goes in. So these are some of the Boolean instructions which are present in the PLC. Then there are arithmetic instructions like addition, subtraction. There are comparators that we saw in the previous slide, that is less than equal to, or it can be equal comparison that we are doing, or it is a greater comparison. Same thing over here. You will be just checking the values over here and with the set parameter that you have put. Then there are counters. Again, if there is a conveyor belt and you need to count the number of bottles, and afterwards you need to decide, okay, let's stop this operation because I need to unload these bottles into my basket. So for that, there are different types of counters. For example, there is a count up. It goes from a one value to an incremented value, or there is a count down. So just giving few examples here, and there are timers as well. Like your process needs you to time an operation. Your process needs to go for a certain amount of time, and then it needs to switch to another process or something like that. So these are just very few PLC operations that I have written over here for the sake of time. But you can learn a bit more onto this. As and more you are learning more on these topics. So far, what we have seen about automation, the components of the automation. We have seen what is a controller, very specific, the PLC controller, how in the PLC we have different sensors, we have different actuators, and how they are interacting with the PLCs using the different control operations. And of course, when you need to program the PLCs, you need to have different programming languages. So we looked into the ladder programming, where we saw how using logics, we can perform the operation. All right, I just hope by now everyone is clear with it, because we're going to move into something that will test all of this for you. So let's move on to an industrial case study. All right. So I have put an industrial case study over here, and this is actually put over here just to make you curious. Now I know all of you are from different backgrounds, so don't get intimidated by the case study. I will be also solving it for you all, but just let's look at this industrial case study, and I have put some videos over there so that you can see it on a visual basis as well. So what is the problem statement here? I have two machines, and these two machines are connected via a conveyor system. And there are bottles which are put on the conveyor system. So from the one machine, the bottles are coming out, and into the another machine, the bottles are going in. The problem statement is that you need to automate the conveyor system so that if any of the two machines go wrong, or there is some problem which is introduced, you need to ring the alarm. The alarm system needs to go on so that we all will know, okay, there is some problem. And what needs to happen automatically is that my conveyor system needs to stop. I need the operation which was automated to stop right then and there, because I know my quality is compromised. Something has gone wrong and I want the process to stop. So just for all of you to understand this better, I have put a small video. Just have a quick look at it. You can see the two machines here in purple, right? And there is a conveyor system and there's an alarm over here. So let me play this video for you. It doesn't have a voice. So these are the two machines which will give me the status, and I need to monitor them. All right, so you need to implement automation on what? If any of the fault is detected in the two machines, which are shown over here, you need to ring the alarm and you need to stop the conveyor system, right? So like, as you can see over here, the conveyor system has completely stopped. There is a fault and that's why it has stopped, right? The alarm has gone on. So that is where we need to implement our programming using the PLC programming. Interesting, right? So I will be also solving this, but before that, a very, very quick question to all of you. So in the case study, we just saw how many input devices and output devices are to be used for my PLC programming. Will I be using 3 inputs and 2 outputs? B, 1 input and 3 outputs? C, 3 inputs and 3 outputs? Or D, 2 inputs and 2 outputs? Put in your chat box. Oh, okay. I can speak in Hindi as well. I'm really sorry, maybe in some other session. Thank you, Saurabh. All right, someone had said that 3. Vishnu is saying C. Ravi is saying D. Yes, that's correct. So why it's not C, A or B is because I have already said that there are two machines that I need to, monitor. And if there's any fault in that, so that becomes my input that I need to take in. And what are the two outputs over here? One is the alarm, because it needs to start ringing. It needs to make people aware that yes, there is something wrong. And the second output that I need to control is my conveyor belt. So that is D, 2 inputs and 2 outputs. Right, that's correct. All right, thank you everyone. So let's go to how we solve this. So again, I have put a video over here just to make you understand, because I feel like it's very important that, everyone over here might not have seen how the industrial setup looks like. And since we have seen those setups, just made it visually for you all. So let me just play this video and also speak what is happening. All right, so I have put my two inputs over here. You can see I have named them as I1 and I2. Again, when you are programming, depending upon the PLC that you have used an Allen Bradley PLC, or you have used a Siemens or Omron. It depends upon what kind of nomenclature that they are using. These are not something that are very difficult. You need to just read the manual that comes with it as to what nomenclature you need to use. So I am using over here, just for the sake of making the video easy, as I1 and I2. So these are the two inputs that I am considering for my machine status. So it indicates the status of my machine. And then I would be controlling two outputs, which is the alarm over here. And the second one is the conveyor system, which is present over here. So if there is any fault in I1 and I2, I need to trigger the alarm and, I need to trigger the alarm, and my conveyor belt has to stop. Now, when you are implementing the control logic, and we have seen in the previous study, there are different instructions that we follow. So if there is fault in any of the two systems, my alarm should go, ringing, and my conveyor should stop. So that can be implemented using an OR logic, right? The Boolean logic that we have seen before. So that is where I would be using a Boolean instruction, that is the OR gate. It need not be that one is working, other is not working. I need, like, if there's any fault, I need to use an OR gate. So I'll be using an OR gate over here, where my two inputs would be the machine status. And we know that in the OR logic we connect it in parallel. So this is my first input I1 on top, and the second one is the I2, which I have connected in parallel. All right, and at the output, you will be having what? You will be having an alarm. That is my A. So if any of them fail, I will have to start my alarm to ring. So that's why I have used an OR logic, and you can see that it is implemented on one rung. So this is the one control logic that I have implemented. So the circuit will be complete if any of the faults are detected, or in the case if both of them go faulty. So that is how I have implemented for my first small problem statement, that is for the alarm. My alarm will go on. Now for the second one, once the alarm goes on, my conveyor belt has to stop, right? So that is again, it is something that, when my alarm is not ringing, my conveyor is going on. That means, the operation is smooth. So this is a very complementary case that we are seeing, right? So again, I can implement it using a Boolean logic. And what gate can we use for that? What do you think? What gate I can use, which gives a complementary answer to your input? It's a NOT gate, right? That means if it is, if let me take it a bit back. Yeah, that means if in the NOT gate, my input is at logic 0 or it is off, then my output would be 1, right? It will be just like an opposite of the first one. And why am I doing that basically? I'll just show you in a, oops, I'll just show you in a rung. All right, so I have used a normally closed switch over here, right? That means, in its normal state, my conveyor belt should continuously keep working. That is why I have used a normally closed switch over here, and not a normally open one. Now you've understood why we are using this. So that's why when the alarm would go on, I would want the conveyor to go off, or the conveyor should stop right away. So that's how I have implemented my second logic over here, which is of the conveyor belt. I hope you guys are understanding this. And that's how I have come to the end of my industrial case study. Thank you so much, everyone. My screen seems to have frozen, but anyways, so that was all on the industrial case study so far. And I would like to call Manpreet before I can take up any questions.
Hi, Sana. Thank you for the incredible webinar. I'm sure we all got to learn a lot of new things today. So, before we start taking our audience questions, I had a quick question for you. My question is that as somebody who is new to this domain and is eagerly interested in learning more, what is the right path for me and what are the career prospects in this domain?
Right. Yes, Manpreet. So I think the right path is the one that you guys have taken right away, is to enroll into this webinar and let your curiosity running as to what PLC is. Or so I think a big thumbs up to everyone who has joined this webinar. You are one step into the process of doing it, and what future prospect you have into it. As I have spoken about the various industrial case study which are there, there are a lot of areas into which you can start working, like in the space of industrial automation or AI ML. So there are different fields in which you can work on. Secondly, if you feel ever stuck up that I don't know where to begin in, we have along with Internshala partnered up to have a PLC programming language, where we are talking extensively with respect to 80 odd videos, how to take up this forum. And we have spoken about different operations which are there, so you can enroll into that and see where you're doing. Also, there is this big forum where you can speak to all of us, so you can put in your queries and interact with us. So do enroll into the PLC programming language that we have on Internshala, as well as you can reach out to Practical Ninjas on our channel.
That's right. And for all the keen learners here today, Internshala Training is offering a special 10% discount on our PLC programming training. So you all can just click on the link in the description and go and enroll right now. So now I request you to now take up some questions from our audience in the comments.
Right. All right, so I think Dakshini has asked when the same bottle is coming out from the first machine and entering into the second machine, how does the error occur in the second machine? Okay, so this is something with respect to not just, error that is happening in the operation. It's like, you have sensors over there, and if any of in any of the sensors detect any errors which are happening, we need to stop the conveyor belt right away. It's not about like the bottles are coming out of one machine and entering into another, then only it has to stop. It could be like the fault is there in any of the machines and it has to stop. Folks have asked that which PLCs have been are prominently used. So yeah, I think I have worked on the Allen Bradley, but I'm not trying to be very favoring anything. It was just because that was what was handy with me. So yes, but I think Allen Bradley, Siemens, Omron, lot of ones. The industry is just coming up, and the PLCs used to be so big before that they used to just take up the entire wall of your room, and now they are so compact that you can put them in your pocket as well. So the industry is constantly evolving, and you will never know what would come up. So you just have to be constantly being updated in the market, what is going on. Okay, can you
we have time
explain
for
the
one
function?
more. So
Yes, I will take the. Can you explain the function of NOT gate? Okay, so NOT gate is a very what do we say? It's a very complementary functionality that it performs. So for example, if the input for this is 0, the output would be 1. All right. Now, what I talk about it is when my alarm was not ringing, my conveyor belt was working. And when my alarm started ringing, the conveyor belt had to stop. So in such kind of examples, where that the operation needs to be just reverse or complementary that we use, or opposite, is where a NOT gate is used.
okay, I think that would be all for today. Thank you so much, Sana, for taking out time for this session, and thank you everyone who joined us today. I hope you had a great time learning, and if you want to watch more videos like this, do subscribe to our YouTube channel and press that bell icon. We also have a Telegram community, so you can go on and join that as well and get updates regarding all our upcoming sessions. So we'll see you guys next time.
इसकी भी लग गई, कमाल है यार।
भाई तेरी ग्रेजुएशन कंप्लीट होने वाली है और तू यहाँ बैठ के मटर छील रहा है। कोई ट्रेनिंग कर ले ताकि तेरी नौकरी लग जाए।
करने को तो कुछ भी कर लूं, पर उसके बाद नौकरी कौन देगा? शुरू कहाँ से करूं यार?
इंटर्नशाला ट्रेनिंग से डिजिटल मार्केटिंग, वेब डेवलपमेंट, डेटा साइंस, एनालिटिक्स और पाइथन जैसे बहुत सारे ट्रेनिंग्स हैं जिनसे हो सकती है जॉब पक्की। ट्रेनिंग सेलेक्ट कर और अपना करियर शुरू कर, और वो भी 100% प्लेसमेंट असिस्टेंस के साथ। इंटर्नशाला ट्रेनिंग्स।